Good morning, distinguished colleagues and friends. It is a true pleasure to welcome you to the 10th Asia Symposium on QFD and Innovation here in the vibrant city of Hangzhou. I would like to thank the ASQFD for hosting this remarkable event and congratulate everyone involved on this milestone anniversary. My heartfelt thanks go to Professors Hisakazu Shindo and Xiong Wai for their warm invitation. I also wish to dedicate this keynote to someone who has profoundly influenced my academic path, Professor Yoji Akao. Now I would like to start with my presentation, Beyond Quality, How AI Transforms QFD into an Innovation Engine. After a brief introduction, I will look at the relationship between QFD and AI from two different perspectives. Firstly, we will look at how AI technology can improve the QFD method. Then we will discuss the question of whether the quality of AI applications can be improved by the QFD method. Finally, I will take a look into the future to see how the relationship between QFD and AI will develop in the future. At the end, I will draw a short conclusion. Before we look to the present and the future, let's take a look back at the history of QFD. In the 1960s, Japanese manufacturing faced rapidly growing complexity in customer needs and technological capabilities. Yoji Akao and Shigeru Mizuno responded by creating quality function deployment as a systematic way to translate the voice of the customer into engineering and production parameters. Their key innovation, the House of Quality, allowed multidisciplinary teams to make design decisions that directly reflected customer expectations. Over time, QFD spread across industries and continents, eventually becoming part of global standards like ISO 16355. Notably, the method has proven equally valuable in non-manufacturing fields, such as software and service development. This historical evolution firmly established QFD as a methodological bridge between customer insight and engineering execution. Throughout its almost 60-year history, QFD has repeatedly demonstrated its ability to adapt to changing conditions, establishing itself as one of the few quality methods to retain its effectiveness to this day. Even in the age of artificial intelligence, QFD will continue to provide significant benefits for product development and quality management. This paper addresses two key and closely related research questions. First, we ask how artificial intelligence can enhance the effectiveness, scalability, and objectivity of quality function deployment. Second, we explore how QFD can act as a structured, user-centered framework for developing and evaluating AI applications in a way that is ethical and explainable. These questions are not isolated. They form a feedback loop, where advances in one area can improve the other. The potential is clear: better products built through QFD and more trustworthy AI systems, designed with the same methodological rigor. Let's start with the first research question. How can AI be employed to enhance the effectiveness, scalability, and objectivity of the QFD methodology? Among the numerous possibilities, I have selected three technologies that can significantly increase the potential of QFD, NLP, and sentiment analysis, data-driven weighting, and real-time adaptability of QFD artifacts. Voice of the customer analysis has evolved dramatically. In the past, we depended on interviews, focus groups, and carefully designed surveys to understand customer needs. Today, customers express themselves continuously and in real time, in app stores, on social media, through help desk tickets, and even via IoT devices. The sheer volume and variety of this feedback make traditional manual approaches unfeasible. This is where AI, and natural language processing in particular, plays a vital role. These tools can parse millions of unstructured data points and apply clustering algorithms to uncover latent needs, trends, and pain points that might otherwise remain hidden. The figure illustrates such an AI-driven clustering approach applied to VOC data. Advanced AI techniques like topic modeling, sentiment analysis, and entity recognition allow us to look beyond surface-level customer statements. By processing unstructured data from diverse digital channels, these methods uncover hidden needs and trends that traditional VOC approaches might miss. What's more, they enable us to feed these insights directly into QFD matrices, keeping them current and backed by real evidence. The result is a far more dynamic, holistic, and scalable understanding of customer expectations. The figure illustrates an NLP pipeline that takes raw customer feedback and transforms it into structured, actionable insights. In traditional QFD, the strength of relationships between customer needs and technical solutions has often been based on expert judgment. While experts bring valuable insight, this process can introduce subjectivity and inconsistency. By applying AI and machine learning, for example, regression models and SHAP explanations, we can compute these relationship weights from actual performance data and customer satisfaction results. SHAP, Shapley additive explanations, is a method for explaining the predictions of machine learning models. This transforms the house of quality into a predictive tool. It not only tells us which features matter most today, but can also update priorities as new data come in. Early results suggest that this evidence-based approach makes QFD both more objective and more reliable, enabling it to adapt continuously to a changing market. Today, customer feedback doesn't arrive in monthly reports. It streams in constantly from connected devices, mobile apps, and smart platforms. Real-time QFD uses this data flow to keep the house of quality up to date with no manual refresh required. A practical example comes from Bosch's smart home division, where telemetry from devices is integrated directly into the product development dashboard. AI tools sift through the incoming data, highlighting what matters most and automatically adjusting the priority weights in the QFD model. This creates a truly adaptive feedback loop between how a product is designed and how it is actually used, ensuring development decisions are always aligned with the most current customer experience. The figure shows the data pipeline integrating VOC analytics and QFD prioritization for the Bosch IoT case. AI-enhanced QFD is not a theoretical concept. It's already delivering results in different industries and regions. In China, NIU Technologies analyzed customer reviews using natural language processing. Clustering revealed that motor noise, not often mentioned in standard surveys, was actually a significant driver of dissatisfaction. This led to a redesign of the scooter's acoustic profile. In Germany, Audi combined QFD with predictive analytics to optimize the reliability of battery modules, using field performance data to guide engineering priorities. And in India, an agricultural technology firm built QFD matrices informed by interviews with smallholder farmers and machine learning crop models. This allowed them to create solutions tailored to affordability, soil resilience, and local market conditions. The figure shows NLP clustering reveals dominant topics in scooter feedback at NIU Technologies in China. These examples show how AI can uncover hidden needs, refine priorities, and adapt QFD